Hello, good morning. I am Dr. Mohammad Arif, scientist in the PALAEOMAGNETISM laboratory of Birbal Sahni Institute of Paleosciences, Lucknow. This module I will deal on paleomagnetism facility that exists in the Birbal Sahni Institute of Paleosciences, Lucknow. So what paleomagnetism is? Paleomagnetism studies the permanent magnetic movements or remnant magnetizations that is recorded in rocks, which we refer as natural remnant magnetism, as a function of time and space, thereby concentrating on the directional information contained in the rocks. By providing information about the location and orientation of continents related to Earth's magnetic field, paleomagnetism has played a significant role in our understanding of Earth's processes, particularly with regard to continental drift and polar wander, and it leads to development of plate tectonics. So basically the subject is derived from the rock magnetism, that is the magnetic properties of rock. So the rock magnetic properties is broadly classified into paleomagnetism and environmental magnetism. In paleomagnetism, we deal with apparent polar wander part, magnetostratigraphy, that is polarity of the magnetic field, secular variation of the geomagnetic field, and the rock deformation processes. In environmental magnetism, we deal with paleoclimate and paleo-environmental reconstruction and environmental magnetic pollution. So in 1950, it was discovered that when magnetic minerals cool below a temperature called the Curie temperature, domains within the magnetic mineral take on an orientation parallel to any external magnetic field present at the time it cooled below this temperature. So in paleomagnetism, we deal with the samples, and the samples can be rock as well as sediments. So we collect rock samples using a portable rock drilling machine in the field. So the samples are of, as you can see on the right side panel, the samples are of one cores of length 9 cm and 1 inch diameter. So in the laboratory, these cores were cut into specimens of 2.2 cm height. So in the case of sediments, we collect the sediment samples using a sedimentary corer, soft sediment corer, and these samples were packed in 10 cc bottles. Also we deal with the lake sediments, and we collect the lake sediment samples from different lakes, and at each interval of 5 cm, we collect the samples. So for measuring the remnant magnetization, we use a Jr6 Finial Magnetometer, as you can see in the picture. So Jr6 principle is this instrument operates by rotating a sample specimen at a constant angular speed in the pickup unit. Inside the coils, an AC voltage is induced whose amplitude and phase depend on the magnitude and direction of remnant magnetization vector. The instrument has a sensitivity of 2 × 10⁻⁶ ampere per meter, and it has two rotational speeds. One is high and low. The high speeds correspond to 87.7 rotations per second, and the low corresponds to 16.7 rotations per second. So the measuring range is, we can measure the samples up to 12,500 ampere per meter. So as the rock contains mineral grains of superparamagnetic, single domain, multi-domain grains, carrying paleomagnetism, we need the grains of single domain grains. So in paleomagnetism, we collect the samples, and these samples were subjected to AF treatment as well as the thermal treatment. AF relates to the coercivity of the magnetic minerals, whereas the thermal relates to black blocking temperature. So the instrument which we use is for carrying out AF demagnetization is D2000 AF demagnetizer, which is a computer controlled demagnetization system offering peak AF intensity up to 0.2 Tesla with built-in PARM and ARM. So the instrument supports static as well as tumbling demagnetizing technique. So standard features includes 0.2 Tesla, which has built-in ARM as well as PARM. So for thermal demagnetization, we use a TD48 high capacity dual chamber thermal specimen demagnetizer. We demagnetize the samples in this chamber. The other topic, we deal with environmental magnetism. In environmental magnetism, an array of parameters as well as parametric ratios are in popular use. Rock magnetism parameters are quickly and easy to measure compared to geochemical, sedimentology and paleontological data. When used, they can be enormously helpful in constraining a wide variety of climatic and environmental changes. So the parameters which we deal in environmental is granulometric parameters, mineralogy parameters, and concentration parameters. So the concentration parameter is a magnetic susceptibility, that is nothing but the magnetizability of a material. Saturation isothermal remnant magnetization is an artificial remnant magnetization. In the case of grain size, we have the parameters like anesthetic remnant magnetation, and there are some interparametric ratios, ARM by susceptibility, ARM by SIRM, SIRM by susceptibility. And the other parameters are mineralogy, which is S ratio, IRM acquisition curves, and susceptibility temperature curves. So susceptibility we measure with a dual frequency meter, that is Boddington Instruments UK. So we can estimate the Curie temperature of a sample using this Boddington sensor. As you can see, this drop in susceptibility at 585 corresponds to the temperature of Curie temperature of magnetite mineral. So for inducing an artificial field, we use an impulse magnetizer. So in here, the magnetic field is produced by discharge of energy from a capacitor bank through a coil surrounding the sample cavity. The capacitor bank is first charged to the desired voltage. It is then discharged through a coil very quickly using a high capacity SCR. This is one case study where you can see a sedimentary section where we do the environmental magnetic analysis of susceptibility, S ratio, ARM by susceptibility. Susceptibility relates to magnetic concentration parameter, S ratio relates to the mineralogical parameter, ARM by chi relates to the grain size parameter. As you can see in the susceptibility is high in the bottom part and lower in the upper part. And when in case of S ratio, you can see the dominance of magnetite is there in the bottom part. Means if S ratio is close to 1, dominantly it is magnetite. And in ARM by susceptibility grain size, higher the value of ARM by susceptibility, it indicates the grain size is finer. Another case study is relates to the concentration dependent parameter, susceptibility and saturation isothermal remnant magnetization. And the mineralogical parameter is soft isothermal remnant magnetization as well as S ratio. In summary, magnetic techniques are sensitive, rapid and usually non-destructive, allowing their application to large-scale geological problems. Rock magnetism underpins our interpretation of numerous paleomagnetic and environmental phenomena, yet there are a number of areas within rock magnetism that are evolving rapidly and may lead to new understandings and applications. Monitoring the geomagnetic field changes, that is the reversals of the geomagnetic field and paleo intensity, and searching for links with the evolution of Earth's deep interior helps to understand the kinematic of plates, dynamics of the core and mantle, long-term climate changes through polar wander. I conclude that the state of the Paleomagnetic Lab facility at BSIP is a national facility and welcomes all the concerned students, teachers, scientists to use this facility. Thanks for watching. Hope you enjoyed this module. Have a nice day. Hello, good morning. I am Dr. Mohammad Arif, scientist in the Paleomagnetism Laboratory of Birbal Sahni Institute of Paleosciences, Lucknow. Here we deal with the magnetism of rocks and sedimentary samples. First we go for a Jr6 Finial Magnetometer. As you can see, this is a Finial Magnetometer where we measure the remnant magnetation of rocks and sediments. So the software for this is a REMA 6 software. Here the sample is kept in this holder and we measure the remnant magnetation of the rock like this. We kept the sample and we measure the remnant magnetation of the rock sample using these icons. After measuring the remnant magnetation of the samples, as you know that the rock contains a variety of minerals like multi-domain grains, pseudo-single domain grains and single domain grains. In paleomagnetism, we are interested in tracing these single domain grains. For tracing the single domain grains, we have to go for demagnetization. For demagnetization, we have an AF demagnetizer which can be applied up to 200 millitesla fields. So each step we apply like 5 millitesla we apply field and we measure the remnant magnetization here. Then we record the direction like inclination as well as the intensity. Then again we apply a field of 10 millitesla and we measure the remnant magnetization. So we go up to 100 millitesla where the directions are constant, like declination, inclination are constant. That directions will give the paleo direction of a rock sample. So in some cases we have to go for thermal cleaning. The thermal cleaning is this instrument. It consists of two ovens. One is an oven for heating, another oven is for cooling of the samples. So this thermal relates to the blocking temperature of the magnetite mineral or hematite mineral. So we successfully heat from 50 to 600 degrees centigrade. Each time we heat a sample like 50 degrees, we heat the sample and we measure the remnant magnetation using a Jr6 Finial Magnetometer. So where the directions are constant, like declination, inclination are constant, that direction is a paleo direction of the rock or sediment that is deposited. So for inducing an artificial field, for characterizing the rock minerals, we use an impulse magnetizer. Like we want to know what is the mineralogy that is carried in the samples, whether it is a magnetite or hematite. So we know that by inducing this artificial magnetic field, we come to if the magnetization is constant at 300 millitesla, that is saturated, we can say that the mineral that is dominant in the sample is magnetite. If it is not saturated, then that sample contains hematite mineral, that is a weathering product. So the basic measurement we carry out for measuring the samples is the magnetic susceptibility. Magnetic susceptibility is nothing but chi, which is nothing but m by h, magnetizability of a material in the presence of a weak magnetic field. What is the concentration of magnetic mineral that is present in the sample? This sample is a summation of contains summation of magnetic minerals, dia, para and ferrimagnetic minerals. So this is a sediment, this is a rock sample, and for these sedimentary samples we use this bottle. So in the field we drill the sample using a portable rock drilling machine. It is powered with a gasoline power and attached with a diamond drill bit, and we collect samples of 10 to 11 centimeter long of 1 inch diameter, and in the laboratory we cut the specimens of these sizes, like 1 inch specimens.